The symbol sigma looks something like this. It's like a reverse E. That's how I always thought about it. Now, sigma means sum of. And you might be thinking to yourself, wait, I thought Sn meant sum of. It does. Sigma also means sum of. However, the difference between Sn and sigma is that sigma has limits to it. So you're going to have a value here and you're going to have a value here. That's like the upper and lower limit. The way we write the lower limit is r equals and then something. And then the upper limit will be just the number. And then here, you're going to have whatever your function is. So, for example, let's say you had sigma r equals 1 and then the upper limit is 5 and your function is 2r minus 3. This will give you or this will allow you to work out your series. So let's plug in r equals 1 into our equation. 2 times 1 is 2, minus 3 is minus 1. That's how we get the first term. The second term, we're going to use r equals 2. So r can equal 1, 2, 3, 4, 5 in this case. That's essentially how it works. So once you plug in r equals 2, you get 1 because 2 times 2 is 4 minus 3 is 1. The third term, 3 times 2 is 6 minus 3 is 3. 4 times 2 minus 3, 5. 5 times 2 minus 3, 7. And then we can now work out the sum of this arithmetic series. It's arithmetic because we have the same number adding or subtracting every time. Okay, so the general, I guess, general formula, yeah, I guess that works, for sigma is r equals 1 and then n here. Cool. Let's have a look at something like this. You have r equals 1 and then the upper limit is 20. So you're going to have r equals 1 plus r equals 2 plus r equals 3 all the way till you get to r equals 20. And then you've got your function 4r plus 1. You want to work out the sum of it. You don't have to write all 20 terms because you know that the sum of equation for an arithmetic series is n over 2 bracket 2a plus n minus 1 d. Okay? A we get by summing in r equals 1. When r equals 1, we get 4 times 1 plus 1, 5. So we know that a equals 5. If we work out the second and third term, so r equals 2 and r equals 3, we will then be able to work out what the common difference is. So 4 times 2 is 8 plus 1 is 9. 3 times 4 is 12 plus 1 is 13. The common difference, therefore, is 4. And n is 20 because the last number here, the upper limit, is 20. So now we can work out S20 by substituting those values in. And when you do that, you get 860. So though the question looks very simple, there's a bit more to it. There's a bit of working out. Okay, let's have a look at something like this. We're going to do the same thing as before in part A. So 5 times 3 to the power of 1 minus 1 gives you what? Just 5. Because it's going to be 5 times 3 to the power of 1 minus 1. So 5 times 3 to the power of 0, which is just 1. That's the first term. What's the second term of that series? 15. And then the third term would be 45. Okay? Cool. Now, you can again do the use the sum of equation. However, we're multiplying now, which means it's geometric. It's not arithmetic. A equals 1. A equals 1, R equals 3, and N equals 12 for part A. So the sum of equation we're going to use is R to the power of N minus 1 all over R minus 1. Plug all that in, simplify it, you end up with 1,328,600. Okay, hope that made sense. Part B. Here's how it works for part B. You want to split the sum of limits. Here's what I mean by that. You're trying to work out 12 to 5. Sorry, other way around. You're trying to work out the sum from 5 to 12. However, generally, when you are calculating, your lower limit has to be 1. Okay? So if you want to actually calculate it, you have to do this. So here's what you can do. If I make like a number line, 12 to 1, what I can do is I can work out 1 to 4. And I can take that away from 1 to 12. What I'm going to be left with is essentially 5 to 12. I've taken away 1 to 4, I'm left with 5 to 12. So, if I do this minus the sum of 1 to 4, this will leave me with that. So you're going to have to do it twice. Technically, we've already done it once. Here, we worked out 1 to 12. And now take away 1 to 4. So can you calculate what the sum of will be from 1 to 4? So the calculation will be 5 times 3 to the power of 4 minus 1 over 3 minus 1, which gives you 200. So you minus 200, you get 1,328,400. That is the sum from 5 to 12. Okay, I hope that made sense. I've put 2 questions which I want you to try, question 4a and 5a. Give those a go for me, please. Alright, let's do 4a. We want to work out a, we want to work out d. It's an arithmetic series because there's no multiplier, it's only subtracting. So when we plug in r equals 1, we get a equals 5. When we plug in r equals 2, we get what do we get? 3. And then when r equals 3, we get 1. So 5, 3, 1. That is the first 3 terms of our series. Technically, if we wanted to, we can also work out the last term. R equals 20 will give us minus 33. So plus blah 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 plus minus 33. The Sn equation is n over 2 bracket a minus L. Sorry, a plus L. Yeah, so there was the 2a plus n minus 1d, and then there was the a plus L, provided you have or can work out the last value, the last term. So S20 equals 20 over 2 times 5 minus 33. That gives minus 280. If you used the other formula, it would still work. You should still get minus 280. Okay, let's try 5a. So in this case, you're going to do 1 to 30 minus 1 to 8. Okay, so we need to first work out the first term. 5 times 1 is 5, minus a half is 4.5. So the first term is 4.5. The second term will be 9.5. And the third term will be 14.5. The last term for S30, so when n equals 30, the last term will be 149.5. Okay, so S30 is 30 over 2 times 4.5 plus 149.5, which gives us 2,310. If we consider n equals 8, the last term in this case will be 39.5. So S8 will be 8 over 2 times 4.5 plus 39.5, which gives us 176. Now, if we do 2,310 minus 176, which is S30 minus S8, we are left with 2,134, which is the same as S9 to S30. Sorry. Which is the same as the sigma notation for r equals 9 to 30. Okay, that's 5a done. There's one more question I want you to try. Question 10. Can you give that a go for me, please? Okay, same principles apply. We need to work out A, we need to work out D or potentially L, and then N. So to work out A, we plug in R equals 1, which gives us 11. To work out the last value, which we can because we know the upper limit is K, we plug in K, 8 plus 3K. And we know that N equals K as well. It's an arithmetic series. There's no multiply going on. So Sn equals n over 2 a plus L. So K over 2, 11 plus 8 plus 3K, which simplifies to 19 plus 3K. They've told you that the sum of equals 377. So let's make this equal to 377. And now it's just a matter of expanding and simplifying. 19K plus 3K squared equals 754. You take the 2 to the other side and then you multiply out the bracket. 3K squared plus 19K minus 754 equals 0. And now factorize. 3K plus 58. And K minus 13 equals 0. K equals minus 58 over 3. K equals 13. I think I jumped ahead. Sorry. Yep, we showed that. Cool, that's done. Hence, find the value of K. Okay, so this is part B. K is equal to 13 because K has to be greater than 0. So it can't equal minus 58 over 3. It has to equal 13. And there you go. That is how you work with sigma notations.